Within ASAP, any number of forms of radiometric analysis, photometric analysis, radiometric analysis, intensity, irradiance, etc., can be performed. Let's take a look at several sample calculations. And I'm going to open up a file. And in this particular case, what we're going to do is simply define a source and then do some statistical analysis on that information. And then we'll look at some of the graphical output that ASAP can create based on, in this particular case, an emitting rectangle. So we have just a rectangular source, 0.5 millimeter across, so 1 millimeter square, and from it we're going to launch 1 million rays and look at some spots and directional information about the source. And we'll let ASAP complete the calculation, and then we'll look at some of the information that we've got available. Okay, and let's take a look at some of our analysis. The flux density, by default, the emitting rectangle is Lambertian. There is also an ISO option that you can just type at the end of it if you want isotropic data. You could also have put an apodization or applied an apodization function to the data. But this is what I would expect for the flux density of a Lambertian source in watts per square millimeter. And here's a contour plot of the same data. If we look at the projected flux density, again, the same information. And here's our angular flux density in direction cosine space. We can also look at all of our data in angle space as well. So whether you need direction cosines or angle space, it's a simple calculation within ASAP. With the radiant command, what we can look at is the far field incoherent intensity of our Lambertian source, and we can see the expected fall off. And here's the radiance in watts per steradian per square millimeter. And what we do now is rotate the source plus and minus 45 degrees, and again calculate the same information. So within ASAP, once you've traced the rays through your optical system, you can perform any number of calculations to get any type of radiometric information without having to trace the rays through any additional times.